In this video, we're going to be solving a rational inequality that has special case solution set. So normally we would begin by taking the equation, get everything on the same side of one of the inequalities, but we already have that here. We already have our x squared divided by x squared plus 4 is on one side and the 0 is on the other. So now we can go straight to taking this equation and setting it equal to 0. And then solving for x. So you'd multiply both sides by the denominator, and that's going to go away. And that's going to give us an x squared equals 0, which means we're going to have x equals 0. So 0 is going to be our only boundary point. And the reason that 0 is going to be our only boundary point is because it doesn't matter what we plug into the x's spot. Because it's an x squared, we will never be able to have a 0 in the denominator. So for all of those real numbers x, we're going to have a non-zero real number there. So our only boundary point is the 0. So if we draw our x-axis and we put our boundary point of 0 and we have a number that's bigger and a number that's smaller. So if I go ahead and plug in my -1 and my 1, I get 1 over 5 for both of my solutions. So the fact that we're looking for where x is greater than or equal to 0 happens on this side and on that side. And so it happens for all real numbers. Now in this particular situation, because it says x is greater than or equal to 0, when we write our solution set, we're able to say that our solution set goes from -infinity all the way to infinity for part A. Part B is a little bit different because it's saying strictly greater than, which means the 0, the boundary, doesn't actually get to be part of our solution set. So we can go from -infinity all the way to 0, but then we need to stop. But we can pick back up again at 0 and go all the way to +infinity. So what happens when we're looking for less than or equal to 0? Well, we just talked about how it's impossible for there to be a negative. Everything is positive. And so here, we're going to have the only spot where we can be less than or equal to 0 is literally at 0 itself. And then when it's just strictly less than, that's impossible. So that's our empty set. Or in other words, no solution. Because that's not possible. And so that's how you solve these inequalities. Let's take a picture of look at the graph, just so we can get an idea visually of what this might look like. So here we can see a picture of our graph, and we can see that it never drops below our x-axis. It's positive all the time. And so that's why our solution sets are what they are. So this was an example of how to solve rational inequalities that have special case solution sets.